Laws of limits. We're going to look at 4 laws of limits today. First one, the sum rule. If you have the limit of one function plus another, we calculate the limit of the first one and add to it the limit of the second one. Meaning, let's say we have the limit as x approaches 3 of 2x squared plus 5x. What we're going to do is calculate each limit separately. So we do the limit of 2x squared as x approaches 3, and then the limit of 5x as x approaches 3. So let's do that. Put the 3 in, we'd get 2 times 3 squared. Put the 3 in, we get 5 times 3. 9 times 2 is 18, plus 15, final answer 33. And you might look at that and say, that's what I've been doing all along. And that's terrific. So I'm just telling you that you've been using this sum rule and that you're allowed to do what you've been doing all along. So the limit of a sum of 2 expressions is the sum of the limit. The product rule. If you have the limit of 2 functions multiplied together, you calculate the limit of the first one, multiply it by the limit of the second one. For example, our first function is x squared, our second one is x plus 1. We'll calculate those 2 limits and then multiply their answers together. As you approach 4 for that one, we get an answer of 16. So we approach 4 for that one, we get an answer of 5. So 16 for the first one, 5 for the second one, answer of 80. And again, I expect you're looking at that and saying, I was already doing that. So that's terrific. So how nice to have a rule that is pretty much obvious. The limit of the product is just the product of the limits. Let's try another one. Quotient rule. I suspect you might be able to figure this one out on your own. When you have a quotient and you're calculating its limit, you take the limit of the quotient of the limits. So you have the limit of a quotient, you calculate the limit of the numerator, divide by the limit of the denominator. Example, here's our top function, calculate its limit. Here's our bottom function, calculate that limit. As we approach 1, we're going to get 2 times 1 squared plus 1 on the top, 3 times 1 squared plus 1 on the bottom, final answer 3 over 4. And again, I expect you were doing this anyway. So why are we doing this? 1, to tell you that you're allowed to do it, and 2, here's a new one. This one's not so obvious. The limit as x approaches a. Do you see anywhere to put a? No. So x has no impact on this. So the answer for this one is k. When you have a constant function, it is constant. Let's take an example. As you approach 3 for the function 8, your answer is 8. Why is that? Here's the graph of y equals 8. Y is always, always, always 8. So it doesn't matter what you're approaching. If you're approaching 3, the answer is 8. If you were approaching 5, the answer would be 8. If you're approaching -3, the answer is 8. Why? Because it's constant. So when there's nowhere to put the x has no impact. You end up getting what you started with because the function is always in the same place. That might be the only one that's a little bit new to you. And it might help you do some questions that you might have had trouble with in the previous exercises. Your job today, goodness, that looks like a lot, but they're all individual limits. Do the best you can. Essentially, you're doing what you've done all along. This rule might help you out a little bit today. Just get lots of practice and get yourself good at limits.